Hello students, derivation, and if it is a lengthy one, has always put the students in trouble, and they find difficulty in dealing with the lengthy derivations there. So in today's discussion, we'll discuss how to deal with lengthy derivation and what is the usual practice which has been adopted by the students there. The usual practice is there to memorize it completely. This is the one which is done by most of the students. If it is a very lengthy derivation, they just try to memorize it. Of course, one more way is there where the student try to understand it, but just understanding of the derivation simply means if they have understood how it has been simplified from one step to another, they think it is enough. But in the examination, if it is asked there, they will find it difficult to recall everything and write in the examination. That is why many times the students find it easy to memorize it, but keeping it memorized also creates problem. There are many demerits when they memorize it, a particular derivation there. First thing is that it is mechanical and boring. You are memorizing it, so definitely they don't develop any interest for that particular part there, and it becomes a very mechanical one, and no concept building is there, because if you are memorizing it, you are not trying to understand it properly, you are not developing any concept of the particular chapter, and gradually that will help you to get detached with the subject. And of course, this is also a not very trusted method in the examination. Why we are calling it as not a trusted method? Because many times it happens that students have memorized any particular derivation. When they try to write in the examination, they get struck midway when they forget the next step, what they have to write. And also they make silly mistakes there in the derivation. Now, why it happens? Just because if you have memorized any particular derivation, in that case, when you are writing in the examination, in that case, once you are writing the first line, you will try to recall the second line, which you will be writing after that. When you are writing second line, you will try to recall the third line. So basically, your brain is doing two work. One, what you are writing, and at the same time, it is also trying to recall the next line which you will be writing after that. So basically, you are not focusing on what you are writing because you are trying to recall the next line which you will be writing. So in that, chances are there that you will make silly mistake. You wanted to write mv square, you have written mv. Because you are not seeing what you are writing. You are basically trying to recall the next line. And if it is a lengthy derivation, what happens? Gradually, as you are proceeding there, in that case, that fear will come somewhere in the mind that you may forget. So in that case, what we try to do, we try to finish it as soon as possible. That is, before we forget, we try to finish it. And once you are doing that, definitely you will make more mistake there. So this is the reason why if you are memorizing any particular derivation, you will not be able to write that entire derivation properly and completely in the examination. Let's take one example. This is one derivation where it is the velocity of the two bodies have been asked after one-dimensional elastic collision. This is a lengthy derivation. You can see there we take the two equations there, and that is the equation of conservation of linear momentum. When we take the conservation of the kinetic energy, then from these two equations, we try to find out V1 and V2, which are the velocity after one-dimensional elastic collision. This is a very common derivation which is often asked in the examination. And here, the student just try to memorize that. Take another derivation, which will be in class 12 syllabus. It is the expression for energy of an electron in an orbit in a hydrogen atom. So, how we can do for this long answer type questions practice there? And in fact, if you are memorizing it, as I told you that there will be problem there when you are trying to write that one in the examination. So for doing long answer type questions or derivations practice there, take help of Google Map. What is that? You all have used Google Map. Suppose you want to go from one place to another place. We put our present location, then we put the destination, and the Google Map will show you the entire route there. If it is a guided tour there, then with the voice command, it will tell you how you have to proceed. So suppose for first case, this is telling you that from where you have started, it is telling you to take a right turn after 230 meters. Then next is that after some time it is showing you that you go straight there up to 1.7 kilometer. So in this particular part of 1.7 kilometer, this Google Map is not going to disturb you with their voice command. So you can go in that particular route there straight. And only when you are going to take a turn there or the turn is approaching there, then it will give you the command that now after say 110 meter, you have to take a left turn. So this is how the Google Map helps you in reaching from one place to another. So it is basically telling you the points where you have to take turn, you have to change your route. Otherwise, if you are going straight, it will take you that up to say 4 kilometer, you go straight. And only after say 4 kilometer, you will get a turn to right. And when the turn is approaching that all time also, it will help you that now it is only 500 meter left, 200 meter left there to take a turn. Let's see how we can apply that Google Map technique to our derivations. Google Map has only told you this points where you have to take the turn. So after that, if it is a straight one, it is a mechanical or straight movement there from one point to another. So let's see if I'm using this one to find the velocity after one-dimensional elastic collision, how we have done that derivation. First, we have taken the conservation of linear momentum. We have got one equation for the conservation of linear momentum. Then it is the conservation of kinetic energy. This is the second equation. And now, since we have two unknowns, that is V1 and V2, that is the velocity of the two bodies after one-dimensional elastic collision, which we have to find, and these two are unknowns, and we have two equations there. So just by using those equations, we can get the value of the unknown. So it is rest part is only simplification. So it will be a mechanical work that you have to do the simplification. So basically what you have to remember that you are using first conservation of linear momentum to get one equation, conservation of kinetic energy as the second equation, and then you are solving these two equations to get the value of V1 and V2. So only this much you have to remember. Rest is just a mechanical part of the derivation. That is simplification. With that, you can get the value of say V1, and you substitute the value of V1 in the other equation, you will get the expression for V2. So this is how you can use this Google Map there. You don't have to memorize the entire derivation. You just remember the steps which you have to use. Same way, suppose if I'm using it to find the expression for the energy of electron in any particular orbit. In that case, what we have to do? Basically, you will get the expression for energy once you have the expression for the potential energy, once you have the expression for kinetic energy. As a sum, you can get that, the total energy. To get the kinetic energy of electron as well as electrostatic potential energy in any particular orbit, we need the expression for the velocity and radius. So we need to find out. So how we can approach that. Let's start with the expression for the electrostatic force between the electron and the nucleus. Next is there, we'll take the expression for the centripetal force, because if the electron is orbiting around the nucleus, in that case, this centripetal force will be provided by electrostatic force of attraction. So we equate that and we get the equation there. So basically now you have two unknowns, v and r, velocity and radius. And now you have the one equation. Also we have the equation of angular momentum, which is giving you the second equation. So now you have two equations. One is this, when we equate centripetal force with the electrostatic force. Another is by condition of angular momentum, you are getting the second equation. Two equations are there, two unknowns are there for radius and velocity. So simply substitute the values there in that expression and get the unknowns. So we'll just try to find out that it is a mechanical simplification that you have to do simply by substituting one in the other one equation there, and you can get the expression for the radius there. And if you substitute in the other one, you can get the expression for velocity. Once you have got the expression for radius and velocity, you can get the expression for the kinetic energy there. Then substitute the value of r there, because that will be required there in the expression for electrostatic potential energy. And when you take the sum of the two, you will get the total energy. So you don't have to memorize the entire derivation there. You simply start that how you have to take. You have to get one equation by equating centripetal force and electrostatic force of attraction. And second equation you can get by angular momentum. These two will involve radius and velocity term. Two equations are there, two unknowns are there. Simple do simplification and get the values of r and v. Substitute these values in expression for kinetic energy, potential energy. You will get the expression there, and sum of the two will give the total energy. So only these steps you have to remember. And if you remember the steps, rest part is only simplification that you have to do. So this is how you can use Google Map technique there for lengthy derivation. You simply remember the steps which you have to follow. Just like in the maps, you know where you have to take the turn. So in the same way, you just remember the basic steps which you have to follow. And rest part is only simple simplification that you have to follow. So for that, you don't need the entire derivation to memorize. Use it for the lengthy derivation, not only in physics, in other subjects also you can try, but definitely in physics that is going to help you a lot. So this is all in today's discussion.